Our presenters for today are Jason Fitzwilliam. Jason is the Precast Solutions Manager for Ultraspan Technologies with over 14 years experience in structural consulting, project management, and precast plant operations. With extensive experience in the production of hollow core, wall panel, and other precast products, Jason works with producers to achieve optimal efficiency in both new and existing plants and has spearheaded the development of several automated plant expansions in North America. Jason remains committed to making automation technology more accessible to precast producers by harnessing the benefits of stationary process automation. Joining Jason is Jordan Watkins. Jordan is a registered professional engineer with extensive experience in structural design, detailing, and project management of precast prestressed concrete structures. As Vice President of PTAC Consulting Engineers, Jordan manages project teams responsible for all aspects of the precast design and detailing, including all three-dimensional modeling efforts. In addition to his role in engineering operations, Jordan is also the manager of the software development branch of PTAC Consulting Engineers, which includes a large suite of software from detailing to production automation solutions. Jordan is passionate about advancing the technology capabilities within the precast concrete industry. I will now hand controls over so we can begin our presentation.
Thank you, Nicole. Hello, everyone, and thank you for joining us today. First, a brief intro to our company. Ultraspan is right here in North America and is part of the Progress Group, with central offices in Europe, along with several manufacturing plants, service centers, and local presence across the globe. Our experience extends to over 55 years of continued support to more than 500 plants worldwide. Innovative technology and a unique in-house precast facility in Europe have contributed to position Progress Group as the leading supplier of technology for the precast concrete industry. In terms of numbers, we are number one in the machinery supply category in the industry, with over 2 million in sales annually, over 650 employees, and customers across 76 countries. Just to give an example of a few automation projects Progress Group has been involved in, here's one of our customers' plants in Thailand. They make product for up to 700 apartments per month and is one of the largest plants of its kind in the world. And here we have a double wall plant in Germany, which is fully automated, operating with a very low labor component, producing well over 10,000 square feet of product per shift, with only a handful of employees in the plant. And lastly, in support of today's webinar, Progress Software Development is our precast software department, where we have a team of software engineers that design and support integrative solutions like AutoCAD and PXML for the precast industry. In addition, we have over 50 plants here in North America. I won't mention any names because most of you are probably with us today, but thanks again for joining. So our objectives for today are twofold. First, to show the benefits of leveraging technology to improve your operations. And secondly, we will be demonstrating this by integrating a wall panel plotter and taking you through the full process from planning to production, integrating element planning and production with automation technology. So on our agenda today, we want to demonstrate 3 basic steps of how the process works to show you how simple and easy it is to bring automation to your plant from start to finish. Number 1, with me today I have Mr. Jordan Watkins, who will be taking us through the element planning and design and showing us what would typically take place within the drawing office to set the stage before production planning and execution take place. After that, I will take you through what happens in the planning office once the engineering and drafting is complete to prepare the PXML data to be used by downstream automation equipment, in this case, a plotter. And then finally, we will show a quick demonstration video showing an actual element being produced using the techniques described in this webinar. But first, let's explore the question, why leverage technology? Number one, and probably the biggest one here on all of our minds, is the labor market, which is basically the fact that hiring, training, and retaining the right people for the job is becoming increasingly difficult across the manufacturing and construction sectors. And the precast industry is certainly no different. In the construction and manufacturing industries, the portion of workers over the age of 55 is increasing, while the portion of workers under the age of 25 is decreasing proportionately. By automating the more tedious and difficult jobs, precasters can use smaller teams, meanwhile increasing worker satisfaction and retention, therefore minimizing the effects of labor shortages. Secondly, we can look at competitive advantages as a reason for leveraging technology. In the new technological era, early adopters will benefit from leveraging technology before their competitors. By integrating customized technology into their production process, they can unlock advantages which propel their businesses to new levels of growth. Next, we can also look at safety and safety regulations. Less workers on the floor means less potential for injury and other worker-related liabilities, as well as the obvious lost time incidents and insurance claims. Also, in these times with COVID-19 upon us, social distancing becomes more manageable with smaller teams. And finally, we can also look at quality as a reason, which is basically that producers can eliminate major sources of errors which result in costly rework and replacement of defects. Anyone who's been involved in manufacturing and has studied lean operational principles knows that the cost to rectify defects increases exponentially the later that the defect is addressed in the process. Therefore, for the sake of the bottom line, precasters will want to ensure that defects are eliminated or addressed as early as possible. So to guide us in our discussion today and to illustrate the plotter integration process, we follow these 3 easy steps outlined here, which are step 1, the design and PXML output, the files that you need to automate with. So that is drafting of all the elements that you'll be producing and then taking it and outputting it in a PXML format. Secondly, we'll be looking at step 2, which is the preparation of the plot file. Once all of the files are output from the CAD system, organizing those files into a single file, which we call the plot file, which will represent the entire bed layout. Once we're happy with that, then we can export that file to the production floor. And then finally, step 3, which is production, which is essentially loading that plot file onto the plotter and pressing start. Easy as 1, 2, 3. So with that, I will hand control over to Jordan to take us through the first step of the process.
Thanks for the introduction, Jason and Nicole. For a bit of a background on PTAC Consulting Engineers, PTAC has been in the design and detailing business of precast pre-stressed concrete for 30 years in North America. In conjunction with our design efforts, PTAC has developed a seamless 3-dimensional modeling solution for engineering and drafting with our product Edge. The Edge platform provides the precast concrete industry a comprehensive solution for project design, estimation, production, erection, and much more. Within Edge, there are 4 pillars that compose this platform. Edge for Revit utilizes the world's most preeminent graphics software to facilitate the creation of detailed 3-dimensional models, which can be translated into accurate bills of materials and shop tickets, allowing for a seamless workflow from the estimation to erection phase. In combination with Edge for ERP, Edge for CAM, and Edge for Cloud, users can optimize all facets of their business. The first pillar, Edge for Revit, is a suite of tools that enhances Autodesk Revit's experience for the precast concrete workflow. Edge for Revit makes modeling precast concrete structures on the Revit platform more intuitive and simpler than ever before. The custom content provided with the Edge for Revit package gives users the ability to easily model complex geometry. Edge simplifies the reinforcing process by automatically marking all reinforcement according to the user specifications and allowing users to easily copy and detail reinforcement amongst similar pieces. Once the three-dimensional model is complete, translating the information into accurate takeoffs, erection drawings, and shop tickets is a simple task. All schedules, erection drawings, and shop tickets are derived directly from the three-dimensional model, making change management simple. Any geometric and dimensional changes made in the model will automatically be reflected on all relevant erection drawings and shop tickets, as well as production automation files. If quantities for any materials in the model are modified, then the corresponding schedules will also automatically update to reflect the new counts. Often, scheduling must occur on various portions of the model, such as a production schedule for precast components or a bill of materials for hardware. With Edge for Revit content and parameters, customizing schedules to the desired level of detail is easily achieved with Revit. Additionally, Edge for Revit facilitates project management by tracking each precast member in the model throughout its entire lifecycle of the project. This allows users to easily identify which precast members have been reinforced, track the creation of their shop tickets, and quickly identify when a shop ticket is ready to be released for production. The second pillar, Edge for ERP, leverages the user's model to extract information that can be directly imported into many common enterprise resource planning systems. It gathers pertinent information from elements in the model and converts it into a file which can then be utilized by the user or directly integrated into the ERP system. This allows for accurate material counts that can be depended upon. Also, Edge tracks each precast element in the model throughout the vital stages of its life cycle. Users can quickly and accurately determine the number of marks and pieces in the model, quantify elements with reinforcement added to them, and track the creation and issuance of shop tickets. The next pillar, Edge for CAM, which we'll focus heavily on today, optimizes and automates the downstream processes of the precast production. Edge for CAM allows users to take their Edge model data and export assemblies to a file that is formatted to be compatible with much of the machinery used to automate precast production today. The exported file contains information about finishes, blockouts, rebar, embed placement, and much, much more. The final pillar, Edge for Cloud, streamlines the production process by providing production personnel real-time information directly from the Edge engineering and drafting model through a paperless mobile application. Assemblies and shop tickets are easily exported directly from Edge from Revit to Edge for Cloud, which can then be accessed on a mobile device or PC, making the communication between production and engineering easier than ever before. For example, if engineering revises a piece, they can easily update the information on Edge for Cloud, providing production personnel immediate access to this revision, eliminating the need for typical document control. Edge for Cloud offers interactive two-dimensional and three-dimensional views, allowing production personnel the ability to easily interpret what is being built. It also makes the entire quality control process paperless and digitized, while still conforming to the recording requirements from many governing organizations. Now to take a look at a few of the specific key features that make Edge for Revit such a powerful tool for the precast concrete workflow. These tools were implemented to automate tedious tasks. For example, piece marks are automatically assigned based on the likeness of precast members in the model, while considering factors such as plate placement, strand pattern, and the overall geometric shape of the precast member. Another tool allows the users to easily obtain the center of gravity and other relevant section properties from a single precast member a group of precast members, or the entire project to be used in design efforts. Additionally, warping a model to allow for drainage is easily achieved with Edge. Based on user-defined changes in elevations, precast members and their adjoining connections will be automatically warped and sloped. This allows users to visualize the complete model in both phases of the precast lifecycle, as it is cast and as it is erected. The ability to create custom product and material takeoffs as well within Edge for Revit is a great advantage, eliminating the need for manual counts of material as we've had to historically do. Furthermore, this ability allows users to leverage Edge for Revit in the early phases of a project to qualify estimates and ensure accurate counts. Finally, Edge for Revit allows for automation of the production shop ticketing process. Edge will automatically generate full shop tickets for multiple precast members at once, while also automating tedious tasks in this process, such as dimensioning, calling elements out, and schedules. Edge for Revit allows users to finally harness the power of Autodesk Revit within the precast concrete design and detailing workflow. As shown in the video, Edge custom content can be utilized to yield a complete model that includes foundations, precast members, steel bar joist, connections, reinforcement, and lifting and handling. An assembly can then be produced based on the precast concrete member and all of its associated materials. Utilizing user-defined information, Edge can automatically generate a fully detailed shop ticket based on the assembly. This shop ticket can include custom views of the assembly that are filtered to only show the desired elements of the user. As you can see, the view on the far left shows embeds and lifting, whereas the view on the right only shows reinforcing. Each view will include dimensions for the precast concrete member and dimensions and callouts to relevant materials. Also, a bill of materials is included in addition to general information about the precast piece, such as weight, overall size, and counts. This third view you're seeing here was generated off of the sheet for the purpose of exporting to Edge for CAM. This view was customized to only show the formwork to be exported to the plotter file, as you will see for the remainder of this presentation. Next, I want to focus on a few of the key features of Edge for CAM. Edge for CAM stands for Computer-Aided Manufacturing and gives the users the option to export an assembly holistically or export a tailored assembly view. These tailored views can be customized to show only certain elements within the assembly itself. Seen here, the views were filtered to only show reinforcement in one case and plates and lifting in the other. This is easily accomplished in Edge by applying view templates to the desired views. You can also customize how materials are displayed in the export. For instance, a plate could be represented in the export as a bounding box, a line, or a single point. This all is in an effort to facilitate the customization of what will be plotted on the bed at the production floor. In this example, the assembly views from the previously generated shop ticket will be utilized to export CAM files. The view on the right side of the screen was configured in Revit to only show reinforcing. Therefore, the exported CAM file will reflect this as well, which is shown in the blue AutoCAD window to the left. Next, the assembly view on the left in Revit was tailored to only show plates and lifting in the exported file shown in AutoCAD. The lifting materials are represented as a bounding box, whereas each of the plates were customized to be shown as a single line instead, optimizing the plotting process. As mentioned, Edge for CAM can be utilized to support a wide array of production automation processes. The exported files can be used for bed plotting, as we're focusing on today, to visualize elements, as Jason will further show later in our presentation. These files can also be utilized for automation of rebar bending, automation of mesh fabrication, allowing for on-time delivery of mesh and rebar, customization and optimization of wire layout, and eliminating the need to stock mesh in inventory. Additionally, the exported CAM files can be used to automate concrete distribution and the placement of formwork. Ultimately, Edge for CAM allows for automation to the production process at the desire of the precast concrete producer. Any or all of these automation processes can be tailored to individual production workflows and needs, allowing for greatly reduced labor requirements and the potential for human error, as Jason has already alluded to. In the following example, I'm going to show an assembly that was filtered down to only represent the formwork. This assembly will then be exported using Edge for CAM. When exporting, the user can choose to either export all assemblies contained in the assembly itself, or to only export the elements visible in the active assembly view. This further illustrates the ability of Edge for CAM to be tailored by the user. Additionally, the user will control what file format it will be exported, either PXML or Unit Technic. The export is then saved, as you have seen, to a selected file format to the defined location on the user's computer. As shown in AutoCAD here, we can see all of the information that was extracted from the assembly in Revit, such as the overall shape of the precast member and the blockout shown here. It will also contain detailed information about the piece, such as its weight, its volume, the material or mix that it will consume, in addition to a number of bits of information about the project as a whole. Had this assembly included material elements, such as plates or rebar, then those would show through also in the export in their respective locations. At this point, I'm going to turn it over to Jason to show how these detailing efforts can be used in a real-world process.
Thank you, Jordan. Now that we have our PXML file output from our CAD system, this completes step 1. And we're on to step 2 in the process, which is to prepare our plot file to be uploaded to the plotter. This will typically be done in a production office once shop tickets are released into production. So you see here that I have my folder open with a series of PXML files. These files are combined into a single plot file, which has been prepared ahead of time using the PXML editor AutoCAD. So as we open the editor, we can see the entire bed view is displayed. This file represents all of the plotting data for all 8 elements on the bed, as you can see here on the screen. So what we can do now is to check the plot data for each element using the element directory on the left. We can click on each element in the directory and we can see that a menu drops down containing the plot components contained in each one. With this, we can check all the attributes for each component which relate directly to the plotting contour dimensions and bed position. The bed view can be rotated between 2D and 3D views, or it can be manipulated to a custom view if required. There is also a zoom function so that you can get a closer view to inspect the components. Elements can be offset individually in any axis direction as required, and final minor adjustments of the elements may be done at this point in the editor as needed before uploading to the plotter. So now that we're happy with the PXML plot file, we move on to step 3 in the process by transferring it to the plotter on the shop floor. We can either do that by thumb drive or Wi-Fi, whichever is more convenient. So on the plotter screen, this is what the operator will see. Once he opens the file, all 8 elements are displayed in the data table at the top, similar to the element directory in AutoCAD. On the bottom left side, we have the full bed view, and on the bottom right, we have the detailed element view. For each element, we have the piece number, length, thickness, starting point in the X direction along the bed, and offset relative to the edge axis. The operator is also given a choice if they want to cancel the production of any element on the bed, and if they wish to do so, they will select not to produce. We can also reorder the elements for any reason if we want to move elements around on the bed. Once the operator is happy with the file that he's created here to proceed to plotting, they will switch to the main operating page on the plotter. Once he does that, all he has to do is zero the plotter by pressing Start a File on the main screen and hit the green Go button. And the plotter will now start to move down the line and print the layout we created on the casting surface itself. So now I'll show you the production demonstration, which is step 3 of our process. So I apologize in advance if it's glitchy on your end due to the file size or connection limitations. So here you can see that the plotter is printing the last 3 panels on our bed. It's going line by line, depositing the plot marks on the bed itself. It will be identifying things like panel geometry, blockouts, openings, inserts, and any other attributes that were selected during the drafting process. The ink that's used is a readily available water-soluble solution which cleans up easily with water and doesn't leave marks on the bed or the concrete. As the plotter is working, typically the production team can follow along element by element, installing all of the formwork and insert parts and any other elements that are required in production. Once the plot is complete, the plotter can be transferred to another bed to plot again and continue this operation from line to line. And these plotters are designed to be moved either with the crane or on their own, under their own propulsion, which is also an added benefit in the production hall. So finally, we get a chance to look at the final product here. So these are actual elements that were produced in this video and with the files that were shown in this demonstration. And you know, the results are very highly accurate and much more honed in quality control system. So in essence, this makes achieving a high level of quality very easy for the producer with a very low labor component. As long as the plot marks are followed, the dimensional accuracy of between 3 to 5 millimeters is possible with a system like this. So therefore, the plotter truly is a huge advantage to the precast production as it allows the CAD system direct access to the production floor, eliminating tedious and inaccurate stages of manual bed preparation using the traditional physical shop tickets. So you might say, well, that's all great, but what does it mean in terms of numbers? So here is an example of a before and after snapshot of some typical results from a project that we actually were involved in. And on the left of this bar chart, you can see we have the producer's manual process before anything was done, showing the numbers or the number of workers involved in laying out each panel in blue. As you can see here, it's 2 workers involved in this process. In yellow, we have the number of hours it took to complete the layout of one panel, in this case, half an hour. So red, on the red bar, we can see the product of these two numbers, which gives us the number of man hours for that step. So therefore, 1 man hour is used in that one panel to do the layout. On the right, we have what happened after the plotter was integrated, which shows a 50% decrease in the number of personnel involved because we went from 2 persons to 1 person. And in terms of the time, we have an over 90% reduction in man hours per element, which is a huge savings. So just in summary, following the easy 3-step process outlined today, integration of plotting technology has never, ever been easier. So just a quick recap. Step 1, it all starts in the drawing office with the drafting team working in their preferred BIM environment to create their piece tickets, which are exported to PXML either directly from the software or through a PXML exporter. The second step, the planning office takes over those PXML files from the drawing office and prepares the plot file, arranging the elements according to the daily production schedule. This plot file is then exported to the production queue, and finally, the final step, step 3, on the production floor, the production team takes over and uploads the file to the plotter, hits the start button, and begins production. It's that easy. So this is all super easy, as I said, and has a huge impact on production metrics, which translate ultimately into lower labor, increased competitive advantage, safer plants, better quality control, and all of these contribute to business growth. Before we get into questions, if any questions are not addressed at this time, you can reach out to us directly at these links so that we can help you with anything that you might need to know. Thank you, and at this time I'll turn it over for questions.
Thank you, Jason and Jordan, for a great and informative presentation. We will now start the Q&A portion of our presentation. The first question is Edge compatible with out-of-box Revit?
Hey, thanks, Nicole. This is Jordan with PTech. Yes, Edge is compatible completely with out-of-the-box Revit. In fact, Edge is an industry partner of Autodesk in this development, so it's a very complementary solution between Revit and Edge. Any capabilities that out-of-the-box Revit provides to a user, Edge will also be able to leverage.
Sounds great. Thank you. What is the estimated investment for this technology?
Thanks, Nicole. Investment levels vary for this type of technology based on the complexity of the production system that needs to be installed in. So I can't give an exact number at this time, but certainly if anyone is interested in this technology, I would invite them to reach out to us directly, and we can certainly help them. And my only real answer to that at this point would be it's less than you would expect.
Wonderful, thank you. What is the advantage of using Edge over other 3D software?
Ultimately, Edge is the only three-dimensional software solution for precast concrete specific to the North American precast market. With that said, Revit and Edge will allow you to stay within the ecosystem that your typical architects and engineers are working with and allow for very seamless BIM collaboration.
Awesome, thank you. We do have another question. What other software does Edge work with?
So as mentioned before, Edge for Revit has other softwares that leverage its data from the model, including our ERP system, our cloud system, and our CAM system. Each one of these satisfies different portions of the concrete workflow, all the way from the early conceptual design process and sales process through the production automation, as shown today, and ultimately erection as well too. In addition to that, Edge is compatible with all of the softwares that Autodesk Revit is compatible with as well, such as BIM 360 and the Autodesk Construction Cloud.
Perfect. What process do you use to upload PXML files to the plotter?
I'll take that one. So it's either done by Wi-Fi, if there's a Wi-Fi signal in the plant from the drawing office or production office to the plant floor itself, or it can be done via a USB thumb drive type transfer.
Awesome, thank you. How much time is the implementation process?
In terms of getting a machine working in the plant, that can be as quick as 2 to 3 months. It depends again on the complexity that's required. There's a lot of different factors that have to be considered. For example, if you have multiple bed widths or other mitigating factors, we need to take those into consideration, which may lengthen that period. But we normally say somewhere between 12 to 16 weeks is sort of the minimum time to get a plotter in place and get everything commissioned and functioning.
Thank you. How does the plotter know where the file starts?
So I'll take that one. Basically, within the plot file, there is a 0 point, which is, usually on the first element, or it can be offset from that. And it's kind of like an XY axis, graph type origin. So once you are ready to plot, you just hit start from 0. And that 0 is the position where the plotter is now. I mean, you can have dedicated marks on the bed that you 0 to, and then that will be sort of the initial point from which the plot file will start.
Thank you. We do have another question. How does Edge improve productivity?
Typically, what we see is roughly a 50% increase in productivity from the engineering and detailing lifecycle. We have measured those metrics not only from our internal productivity increases by using our own software Edge with our detailing and design efforts, but also 50 plus customers, businesses that are utilizing Edge throughout North America as well.
Thank you. How much time can you save by using a plotter versus manual labor?
So I think, in the example that we showed there, it's quite evident that, you can save, minutes, if not, fractions of an hour off of each piece. And that, depending on the length of the bed that you're talking about, that translates into, typically between an hour to 90 minutes is kind of the sweet spot that we see for, typical 200 to 300 foot beds in North America.
Perfect, thank you. Can you differentiate plotting between different types of objects?
Jordan, you want to take that one? Yeah, I can definitely take that one. So ultimately, as shown in our presentation here today, you can determine through your Edge templates how an element is plotted. That can be anything from showing the full level of detail of a plate with studs, for example, or that individual plate could be represented with an X, a circle, any type of line work determined. So all of that can be handled in the drafting process using the Edge model prior to exporting to PXML, and then that will ultimately facilitate whatever gets plotted and how it gets plotted in production.
Yeah, we have a term for that. It's called aliasing. So, I mean, it will basically translate certain data into simplified lines and line types for deciphering on the bed what needs to go in that position.
Sounds great. We do have one more question. I have beds of different widths. How does the software know how wide the panel can be? And how does the plotter know if there's room to plot it?
Okay, that's an easy question to answer. So, we have done quite a few projects where producers have multiple bed widths in the same hall using one plotter. And basically at the time of commissioning, what happens is that each individual bed is set up in the plotting environment with a set of limits in terms of, the width. So the plotter will know, okay, on this bed I can start at 0 and end at 12 feet. On the next bed I can stop at 14 feet, for example. So all you need to do is, during the production planning stage and or during the production stage, you just need to tell the plotter which bed you're on, and it automatically knows how much width it has to play with in terms of space. It's very easy.
Sounds great. Thank you for your answers. It does look like that's all the questions we've received so far. We'll give it 10 seconds just to see if another one comes through. Oh, we did get another question. What benefits does a plotter have over laser layout?
So I'll answer that one. In terms of laser layout, there's a lot of limitations. I would call them environmental limitations. So if you're using a laser, you have to be a set distance above the casting surface. There are limitations in North America regarding the power of laser that's allowed to be imported in certain jurisdictions. so that can limit the visibility of the laser. And also the laser has to be on and over the area which is being worked on at that time. So it means that you have to have a very large system, which is many different projectors or a large array of laser projection over the bed, which is quite expensive. Obviously, it can be blocked by overhead obstructions, and it's subject to thermal interruption and also vibration within the building from the cranes, etc. So it tends to be not as great in practice as it is, in theory, to implement lasers. And it's good to have sort of a semi-permanent mark on the production surface that you can work with, throughout that production cycle, rather than something that's transient and subject to environmental changes.
Thank you. And we did receive another question. Could Tekla create PXML?
The answer is yes. Tekla does have the ability to directly export the PXML.
Perfect, thank you. It does look like that's all the questions that have come through. So on behalf of PCI, I'd like to thank Jason and Jordan for a great presentation. If you have any further questions about today's webinar, please email marketing@pci.org. Thank you again and have a great day and stay safe.